You are welcome once again to another video. Today we are considering a geometry question, and the question is this. So let's have a look at the information provided in the diagram. We are given a circle. We have a tangent line. We have a straight line that passes through the diameter of the circle to converge with the tangent line outside the circle. All right. We have this angle as A degrees, we have this angle as B degrees, we have this angle as C degrees, we have this angle at D degrees, and this angle as E degrees. We are given this angle as 40 degrees. The question says, find A, B, C, D, and E. All right. So how do we tackle this question? How do we find these angles when only one angle is given? Although this question appears intimidating, I tell you, this is a piece of cake if you are familiar with the circle theorems. All right, I'll show you how to find the angles. Stick with me. In order to answer this question, you need to be familiar with three circle theorems. First, triangles drawn from two ends of a chord make the same angles at the circumference. This is a chord. And we have three triangles that are drawn from these two ends of a chord. We have this triangle drawn from these two ends of the chord, making this angle at the circumference. We have another triangle drawn from these two ends of a chord, making this angle at the circumference. And we have the third triangle drawn from these two ends of the chord, making angle D at the circumference. These three angles are equal because the triangles are drawn from two ends of this chord. Another theorem we need to know is the alternate segment theorem. The theorem says that the angle between the tangent line and a chord is equal to the angle in the opposite segment. This is a tangent line and this is a chord. So this angle between the tangent line and the chord is equal to the angle in the opposite segment. These three angles are in the opposite segment because their triangles are drawn from two ends of this chord that formed angle 40 degrees with this tangent line. So we can now say that these three angles are equal to 40 degrees. So B is equal to 40 degrees. C is equal to 40 degrees. And D is equal to 40 degrees. All right. Now let us find angle E. For us to find angle E, we need to be familiar with the circle theorem that states that the triangle in a semicircle form angle 90 degrees at the circumference. This angle formed at the circumference is a right angle triangle. So this angle is 90 degrees. Since this is 90 degrees and B is 40 degrees, we can easily find angle E. So angle E is equal to 180 degrees minus 90 degrees minus 40 degrees. So E is equal to 50 degrees. All right. Now let us find angle A. This is a straight line. The sum of angles in a straight line is equal to 180 degrees. This angle plus this angle plus this angle is 180 degrees. So to find angle A, we will use 180 to subtract 90 and 40 degrees. A is equal to 50 degrees. Alternatively, you can use the alternate segment theorem. This is the angle between the tangent line and the chord. This angle is equal to the angle in the opposite segment. We calculated angle E as 50 degrees. So angle E is equal to angle A. So A is 50 degrees. Thank you for watching this video. If you find the video informative, please remember to subscribe to my channel. Remain blessed.